Buried deep beneath American soil, hidden behind layers of steel and concrete, stood the largest missile ever deployed by the United States. The Titan II, an intercontinental ballistic missile capable of launching in under a minute and surviving a nuclear blast, waited in silence during the Cold War for an order that everyone prayed would never come. In this video, we modeled the entire Titan II underground missile launch complex to reveal the engineering that made it both unstoppable and untouchable. But before we get into it, I'm Lion and this is Deconstructed. We break down the engineering behind history's most fascinating machines, vehicles, and structures. Let's see how it all works. First, I want to give a huge thanks to Supremacy World War III for sponsoring this video. The Titan II was built during the Cold War, a period of global rivalry, when the world stood on edge as it anticipated World War III. And in Supremacy World War III, you're living through the war that never was. This free online PvP strategy game lets you command a real country through modern global warfare, building armies of tanks, jets, and even missiles like Titan II. Form alliances, launch surprise attacks, and compete against 99 other players in real time. What I love most is the strategy. You have to think like a real commander. Every choice has consequences. With cross-platform play, you can command from PC or mobile. Use my link in the description to claim your exclusive starter pack, the Elite Bomber, a $25 value for new players only, available for 30 days. So if you've ever wondered what it would feel like to command the power once sealed inside a Titan II missile, this is your chance. Click the link below, claim your rewards, and conquer the world. Now, back to the video. US interest in long-range missiles intensified near the end of World War II, when American engineers studied Germany's V-2 rocket, the world's first long-range guided ballistic missile. Standing 14 meters tall with a range of about 320 kilometers, it was a technical marvel for its time, though still a fraction of what later missiles would achieve. By comparison, the Titan II would reach 31 meters in height and gain speeds up to 25,000 kilometers per hour, roughly 20 times the speed of sound. The first nuclear weapons were too large and heavy for the rockets of that time, so they could only be delivered by bombers. However, by the early 1950s, technological advances made a new idea possible: the Intercontinental Ballistic Missile, or ICBM, a weapon capable of traveling more than 5,500 kilometers. As Cold War tensions deepened and fears of Soviet progress grew, the United States made ICBM development a top national priority. In 1955, two ambitious programs were launched side by side: Project Atlas and Project Titan. Early models, such as the Atlas F and Titan I, were stored vertically on elevators inside underground silos. But before launch, they had to be fueled and raised to the surface, a process that took up to 15 minutes and left them dangerously exposed to attack. Then came the Titan II, which changed everything. By switching to storable propellants, the missile could remain fueled at all times. For the first time, a missile could ignite underground, reducing the launch sequence to less than a minute. The Titan II was in service from 1963 to 1987, during which time 54 missiles were deployed across 3 U.S. Air Force bases in Arizona, Arkansas, and Kansas. It was the largest missile ever fielded by the US, weighing 150,000 kilograms including the propellant, which is equivalent to the weight of more than 4 fully loaded semi-trailer trucks. The Titan II was a 2-stage liquid fuel rocket. Each stage contained its own fuel and oxidizer tanks arranged in tandem, with the tank walls forming the outer skin of the missile. The second stage carried the re-entry vehicle, equipped with a single thermonuclear warhead, a weapon with a yield of 9 megatons, or about 600 times more powerful than Little Boy, the first atomic bomb dropped on Hiroshima in 1945. Its range was an impressive 10,000 kilometers, able to strike its target in just 30 minutes. Ballistic missiles like the Titan II were stored in hardened underground silos, massive structures built of reinforced concrete and steel to survive the shockwaves of potential nearby nuclear explosions. But no amount of hardening could withstand a direct hit, so designers had to determine how much protection was enough. Launch sites were engineered to survive the blast of a 10-megaton nuclear explosion detonating 1.4 kilometers away. Before we dive deeper, we actually turned this video into something you can own. We created a detailed Titan II missile silo poster, mapping out every level of the underground complex, even including details that we couldn't fit into the video. Each of our videos takes hundreds of hours of research, modeling, and animation, and every purchase directly supports the channel and the team behind it. The poster is now available and 10% off for the first 7 days. Grab yours through the link in the description. We're also giving one away. For a chance to win one, comment below what surprised you the most about the Titan II launch complex. We'll announce the winner in the next video. Let's take a closer look at the underground launch complex in which the Titan II was stored. Starting at the surface, the launch complex was fairly unremarkable and pretty easy to miss. A fenced-off patch of land in the middle of nowhere. The site's first line of defense was a barbed wire perimeter fence. There were no guards nor cameras topside to monitor the surface. Instead, security relied on a radar-based intrusion detection system. This system projected invisible beams around the inside of the fence, triggering an alarm if anything crossed them. When that happened, external security forces from nearby bases were immediately dispatched to investigate. Communication was crucial. Inside the complex, the crew's primary duty was to listen for one thing: a possible launch order. So to ensure constant contact, the site used multiple antennas built with redundancy in mind. There were 2 types of antennas: soft antennas, which were exposed on the surface and vulnerable to an attack, and hard antennas, which were kept underground. These hard antennas could be deployed after a nuclear blast, ensuring the crew could still receive commands even if the surface was destroyed. The most impressive feature was the silo closure door. We'll explore how it worked in more detail later. Ventilation for the entire underground complex came through 3 air shafts, which circulated fresh air through the silo and crew areas. And finally, the only way into the facility itself was through the access portal. Beneath the surface, the Titan II complex stretched out like a buried fortress, an inline network of reinforced tunnels called cableways, roughly 92 meters long from end to end, connecting 3 massive structures, each one hardened to withstand the shock of a nearby nuclear blast. At one end stood the Launch Control Center. In the middle was the access portal and the blast lock area, and at the far end was the missile silo. Together, these sections formed a sealed underground world, one purpose-built to ensure attack and strike back within minutes. Let's dive deeper into each section. First, the access portal was the only way into the underground complex. Unlike the hardened structures below, the portal itself was a soft structure, vulnerable in the way the exposed antennas were and not designed to survive a nuclear blast. A 10-meter deep vertical shaft extended from the surface, housing both a stairwell and a freight elevator. A stairway led down to the electrically locked portal door. Inside, another stairwell continued downward. A second inner door, also electrically locked, sat just below the first landing along the stairwell. To enter, personnel followed a strict multi-step phone procedure. The first call was made at the perimeter gate to request the gate to be open. Within 3 minutes, a second call had to be made at the outer portal to request access. If the second call was delayed beyond the 3-minute window, external security forces were automatically dispatched. If crew members were being forced to enter under duress, such as at gunpoint, they could deliberately delay the second call, triggering the security response without having to say a word. Once inside, a third call was made from the entrapment area, a secure cage between the first and second doors. This call required a one-time entry code, which was immediately destroyed by burning the card after use. A visual identification was then confirmed through CCTV before the second door was unlocked. From there, personnel descended the stairway and made a fourth and final call to request the opening of the first blast door, giving access to the blast lock area. The blast lock area acted as the bridge between the outside world and the underground launch complex, connecting the Launch Control Center to the missile silo. Built of reinforced concrete and fitted with 4 massive steel blast doors, it was designed to shield the crew from both nuclear detonations above and potential explosions of the missile within the silo. The blast doors were numbered 6, 7, 8, and 9, split into 2 pairs that formed 2 separate blast lock chambers. Doors 6 and 7 made up the outer blast lock, offering protection from a nuclear blast, while doors 8 and 9 formed the inner blast lock, which guarded against a missile explosion. Each door weighed approximately 2,700 kilograms and was secured by 4 large hydraulically driven steel pins, one at each corner, that locked the door into its frame. Both doors in a pair were electronically interlocked and could not be opened simultaneously. Blast Door 7 led to the inner blast lock area, from which crews could open Door 8 to reach the short cableway to the Launch Control Center, or Door 9 to access the long cableway that extended to the missile silo. The space behind Door 9 also served as a decontamination area for the propellant transferred personnel handling the Titan II's extremely toxic propellants, which could be fatal. It contained an emergency shower and storage for protective suits. Moving deeper into the complex brought you to the Launch Control Center, where launch orders were executed. The top of its reinforced concrete shell was built with a dome shape, designed to deflect and reduce the effect of a nuclear blast above. Inside the shell, a 3-story steel structure hung from the roof by 8 massive shock mounts designed to absorb the ground shock from a nuclear blast. These mounts, each made up of suspension rods and coil springs compressed under static loads. Level 1, the top floor, served as the crew's living quarters. It was divided into 3 rooms: a 2-bunk sleeping area, a kitchen and dining area, and a restroom with a shower. Since crew members worked 24-hour shifts, they needed a place to rest, eat, and decompress between duties. Level 2, the middle floor, held the actual control center, the operational nerve center of the facility, where the crew could receive and execute a launch order. This was where they spent most of their time. The crew typically consisted of 2 officers, the Missile Combat Crew Commander and the Deputy Missile Crew Commander, and 2 enlisted personnel, the Ballistic Missile Analyst Technician and the Missile Facilities Technician. At the center of the room stood the Launch Control Complex Facilities Console, essentially the dashboard that displayed the missile status and the overall conditions of the complex. One of the 2 launch key switches was mounted here. The other we'll see shortly. To the left of the room sat the Emergency War Orders safe, painted bright red, often referred to as the go-to-war safe. It contained the launch keys and message authentication cards needed for launch, all highly classified materials. It was locked with 2 separate combination locks, each known only to one of the officers, ensuring no single person could access its contents alone. Next to the safe stood 3 tall cabinets housing the radio communication equipment. Beyond them was the alternate launch officer's console, which handled all communication and contained the second launch key switch. The 2 key switches were placed far enough apart so that a single operator could not reach both. To initiate a launch, both keys had to be turned within 2 seconds of each other and held for 5 seconds, a built-in safeguard against unilateral action. Around the room, additional panels managed facility power, sight and missile monitoring, launch control and targeting, and the missile guidance computer programming. One of these panels contained the butterfly valve lock control, a combination lock that received its code only with official launch orders. This system was a final failsafe, preventing any unauthorized or accidental launch. It locked shut a butterfly valve in one of the missile oxidizer lines, supplying the first stage engine. Also located on this level was the fresh air intake, an air shaft extending to the surface and fitted with a blast valve. The valve was normally open to allow ventilation, but in the event of a nearby nuclear explosion, the shock wave would travel through the intake, pushing the valve piston shut. The wave was then routed through a delay pipe, whose transit time allowed the valve to close completely before the shock front arrived, protecting the control center from destruction. Level 3, the lowest floor, housed the support equipment. Here were the electrical power distribution systems, complete with battery backup, as well as communication equipment, a sewage storage tank, and an air conditioning unit that cooled the control center. This level also stored emergency food supplies, essential in the event of long periods of entrapment following a nearby nuclear blast. If the main access portal ever became unsafe or impassable, the crew had an escape hatch leading into the air shaft, with a ladder that climbed all the way to the surface. Finally, cableways extended from the control center carrying the vital power and communication lines to the missile silo, the largest structure on site. The silo was built as two concentric cylinders. The outer cylinder, called the silo equipment area, contained every system required to launch the missile. It was divided into 9 levels, with the cableway entering at level 2. Each level served a specific function, and all critical systems were mounted on independent shock isolation platforms suspended by springs to protect them from nuclear blast shocks. A ladderway connected all levels, and an elevator provided access between levels 2 and 8. 6 of the levels opened into the inner cylinder, called the launch duct, each fitted with blast doors and retractable work platforms that allowed maintenance crews to access different sections of the missile within a precisely controlled environment. The duct was 45 meters deep. Near the bottom, the missile rested on a ring-shaped platform called the thrust mount assembly, suspended from the duct wall by 4 massive spring assemblies that absorb vibration and held in place by dampers that could be locked in place to hold the platform steady during launch. The missile was secured to the mount with 4 explosive bolts that detonated just before launch, freeing it from the platform. The duct walls were lined with special acoustic panels to absorb the sound waves generated during launch. But these alone were insufficient. To prevent the missile from destroying itself with the intense acoustic energy generated during launch, a water deluge system was installed beneath the missile's engine. This system supplied thousands of liters per minute through 4 nozzles, absorbing most of the sound energy as the water vaporized into steam upon contact with the missile's exhaust. At the very bottom sat the flame deflector, a massive structure that split the missile's exhaust gases into 2 ducts running upward along either side of the launch duct. At the top, cascade vanes redirected the fiery exhaust away from the missile, preventing damage during liftoff. Capping it all was the silo closure door, a colossal slab of steel and concrete weighing around 700 metric tons, the equivalent of more than 10 fully loaded Boeing 737s. However, despite its size, the door could be opened fully in under 20 seconds. The door rested on 4 dollies, each equipped with 4 steel wheels, which ran along 2 sets of tandem rails. Beneath it, on level 1, sat the door drive system, which was made up of hydraulic motors, a gearbox, and the drive mechanisms that powered the massive door. A long drive shaft stretched across the level, with pulleys at either end that wound and unwound steel cables to move the door. The silo elevator drive system was installed beside it, while the hydraulic unit for the door drive mechanism occupied the opposite side of the level. Level 2 contained water chillers supplying cold water for the air conditioning units throughout the complex. Level 3 housed the silo's backup generator and electrical distribution system. This level and the level below were connected in 2 air shafts extending to the surface, like those in the control center. Beginning on level 4 and extending down to level 6 was a massive water tank that stored 380,000 liters of water needed for the deluge system. Level 5 housed the air conditioning units that cooled the silo, along with a large diesel fuel storage tank. Level 6 housed the system that monitored the missile's toxic propellant vapors, along with the hydraulic unit that powered the retractable work platforms. Level 7 stored air compressors and water pumps for the complex. Level 8 contained a pump for propellant offloading as well as a dehumidifier to keep the launch dock relative humidity below 30%. Finally, Level 9, reachable only through floor hatches in Level 8, contained the sumps and pumps that sent collected water to the surface. Every system inside the silo stood ready, waiting for the order to launch. And if it ever came, the process began with a coded emergency action message transmitted to the 2 officers on duty. They wrote it down, cross-checked it, and verified its authenticity. Then, using the red safe, they retrieved the launch keys and emergency war orders documents and confirmed the command. Crew members powered up the missile's weapons systems and used the enable code from the message to unlock the butterfly valve in the first stage engine's oxidizer feed line. With the final verification complete, both officers turned the launch keys simultaneously, holding them for 5 seconds. In that moment, there was no turning back. The sequence was irreversible. Once initiated, the missile would launch automatically. The missile's batteries activated, transferring power from the silo to the missile's internal supply. Propellant began to flow. The water deluge system flooded the flame deflector, and above, the silo door rumbled open. The thrust mounts locked in place, and then ignition. Explosive bolts fired and the Titan II tore free from its cradle, climbing toward the surface. From key turn to liftoff, the entire launch sequence took just 58 seconds. The Titan II's legacy reached far beyond its role as a Cold War deterrent. Its immense power made it the launch vehicle for NASA's Gemini missions in the mid-1960s, carrying astronauts into Earth's orbit and paving the way for the Apollo program that followed. But progress never stops. The Titan II was eventually succeeded by the Minuteman missile, which used solid fuel instead of liquid propellants. This technology made it safer, more compact, and less expensive. While smaller in warhead yield and size than the Titan II, the Minuteman delivered comparable performance. By the 1970s, the Minuteman had become the backbone of America's ICBM force, and over 1,000 missiles had been deployed. After the Cold War, the Titan II era quietly drew to a close. Its silos were destroyed, except for one preserved historical site, the Titan II Missile Museum in Arizona, where one final Titan still stands silent, a relic of an age defined by both fear and innovation. Quick shout out to our last giveaway winner. Congratulations! And a quick thank you to our Patreon and YouTube members. You'll be getting this exclusive desktop background inspired by today's video. Before you go, make sure you try Supremacy World War III, a free online PvP strategy game set in modern global warfare. Command a nation, battle other players in real time, and conquer the world through strategy. Click the link in the description to claim your exclusive starter pack, the Elite Bomber, a $25 value for new players only, valid for 30 days. Thanks for watching, stay curious.